Welcome back everybody to 30 Days of Python. We are on day 15. We are officially at the halfway point of our journey, and today we're focusing on what programmers deal with on a daily basis: errors. Professional developers don't avoid errors, they master its understanding of it, and it becomes useful for debugging and fixing problems. Now, if you ever ran into type error or value error and felt frustrated, hopefully this video helps in understanding any of these errors. Let's get started. Before we get into the type of errors, let's first change our mindsets towards them. They aren't meant to catch you out, but rather guide you towards fixing the errors. Errors are actually incredibly helpful because they tell you exactly what went wrong, show you where it happened, like the file and the line number, explains why it happened, and stops your program before it does anything dangerous. The key is to read and understand. Let's start with syntax error. This is like a grammar mistake in English. Think of it like Python not understanding you at all in your broken English. So in this example, you can see some of the syntax errors. A missing colon will throw you an error like expected the colon sign. As we know, the colon goes after the condition in an if statement, or after a loop, or after defining our functions. The missing parentheses, like when we want to print to the console, that's one error. The unmatched quotes, like forgetting to close the quotes in a string. This is important as people forget to indent correctly. This message indentation error, expected an indented block, important in nested if statements, loops, and defining functions. Python will tell which line the error occurs on, so read carefully and take note of the line number the first error occurs if there are more than one. Syntax errors mean Python can't parse your code. The fix is usually simple, like we see here. Most IDEs will tell you or even highlight these errors for you before you run your code with it will indicate it with the squiggly lines in red or orange. Now let's look at type error. This occurs when you try to perform operations on incompatible data types, like trying to add different data types together that are incompatible, such as string and integers. There are also function calls with incorrect number of arguments to parameters needed, like calling a function that has 2 or more parameters but only giving 1. Using the wrong type with built-in functions, for example, using the len function to check the length of an integer when the length function is a string function. An error that I always mistakenly make is iterating over things that are non-iterable, like lists, like certain lists that you shouldn't iterate over. So for example, this error will come up when you accidentally mean to loop through a range and forget to put range in the conditions of the loop and just put down the valued range rather than using range and then putting the value inside of it. So the value range you'd like to iterate through is what you do specify there, right? The key with type error is understanding what types each operation expects. When in doubt, use type function to check what you are working with. Next is value error, which is often confused with type error, but they are different. This occurs when the type is correct but the value is inappropriate. The value error is Python saying, I know what you want to do, but the specific value doesn't make sense for this operation. This is a small indication for you to always check your inputs, especially if your program relies on user input as well. Now let's look at some of these examples. It will appear when you try to convert string to numbers incorrectly, like using the int function and passing a string instead of a number inside the brackets. Another is converting to float. This example shows the input with two periods inside the string, making it look more like an IP rather than a regular float. Again, check the inputs before running your code. Now, the next one is a common error with regards to value errors, because it could be done purposefully, in the sense if you don't know how big a list is. This is an alternative way to check. So the list index out of range means that the list index does not go up until what you requested. Like this example, the index value called was 5, but the index range only goes up until 2, because we start counting from 0, not 1, when you're referring to index. Looking at dictionary key errors, it will throw this error if the key does not exist in the dictionary. A string to int conversion by base will inform you that you cannot convert the string to int due to base conversion, like with base 2. Name error and attribute error happen when Python can't find what you're looking for. A name error is using undefined variables, like when you decide to print out the variable that doesn't exist in your code, neither globally nor locally inside a function. A common occurrence due to types in variable names, using a variable before they're defined or forgetting to import modules. Attribute errors occur by misspelling or calling a non-existing attribute, like this uppercase versus upper attribute. The correct version is upper, not uppercase. This happens due to its functionality, since upper turns all the characters in a word to uppercase. Most commonly occurs when using the math module with the attribute square root, which is shortened to sqrt. It is best to do checks on variables to see if it has attributes, like has attribute function and get attribute, to call the attributes and use it if it exists. Now let's talk about how to actually find and fix these errors systematically. The first method is obvious. Read the error message carefully. In this example, we get the 0 division error. The error clearly expresses what happened, why it happened, and where it happened. It's a 0 division error occurring because of dividing by 0 in the calculate ratio function. So the second method is to add print statements for debugging, like checking the parameter types or variables. The third is to use try except blocks to handle expected errors. So this is the same as try catch blocks. It is the best way to find unwanted errors and to alert you to it if anything were to go wrong in the code. This is used in industry religiously. The fourth method is assertions, to catch errors very early. So this does a check on the variables and ensures they are correctly specified or in correct use. Debugging is a skill that improves with more practice. So the more errors you find, the better you become as a programmer. Now let's actually look at the exception handling using the try except error handling function. Essentially, it is a block of code that contains your functions and the code you wish to run. Like I said, this practice is industry standard and is best to practice now and get better at using it. Take the first example. It is basic try catch or try except block. It tries to run the code, which will, but if there are problems within the try block, the error will be picked up and one of the exceptions will be triggered to print out to the console. Pause to go through it. The next exception is multiple exceptions in one line. You can pass multiple exceptions in one line for the except block as seen here. You can also raise custom exceptions where you use the try except block around the calling of a function. This method is the professional standard of writing code for any function, especially if a file contains multiple functions and is being called through the modules inside other files. It is important that if there are any exceptions that need to be raised, it will pass through to the other files as an exception and you will be able to debug the problem. Here are some good practices to follow that will keep your code robust and user-friendly. Be specific in your error handling and not overly broad in the exceptions. Be open about it and try not to hide away from it. Think of it like this. You trying to make the job easier for the next person looking at the code, even if it's you in the future. Make sure you use else for successful cases. That way the code runs through all the necessary error handling and passes successfully. Ensure you log your error properly. Don't just print it out. Also create custom exceptions for your domain, since your code will be custom code and never seen before with all your new functions. Custom exceptions are useful for collaborative work. And another thing, don't forget to leave comments in your code. It's not just important for the next developer, it's important for you because you have amnesia. Every developer has amnesia. So thanks so much for watching. We've gone past the halfway point now. We move on to day 16 where we will be dealing with date and time. The journey is only just beginning, so see you all on day 16.